For centuries, humanity has gazed up at the night sky, marveling at the distant points of light that beckon from the vastness of space. Among these celestial wonders, Jupiter stands out as the largest and most imposing planet in our solar system. A swirling giant, adorned with colorful bands and the iconic Great Red Spot. Its sheer size and beauty have inspired countless dreams of exploration. But as much as our imagination soars, there are fundamental reasons why we will never land on Jupiter. To understand why, we must first consider what Jupiter truly is. Unlike Earth, Mars, or even the Moon, Jupiter is not a solid world. It is a gas giant, composed predominantly of hydrogen and helium with no well-defined surface. As one descends through its thick atmosphere, the gases gradually become denser, transitioning imperceptibly into a hot, pressurized soup of exotic materials. There is no solid ground, no firm place to plant a flag or set foot. But the lack of a surface is only the beginning of the challenges. Jupiter's atmosphere is a maelstrom of extreme conditions. The upper layers are whipped into colossal storms, with winds reaching speeds of over 350 miles per hour. Lightning bolts many times more powerful than those on Earth crackle through the clouds. As you go deeper, the pressure mounts at an astonishing rate. At a depth of just 100 miles, the pressure is already greater than anything experienced on Earth, enough to crush any spacecraft currently designed by human hands. The temperature, too, becomes increasingly hostile. Above the clouds, the temperatures are frigid, plunging to minus 145 degrees Celsius. Descending lower, the heat rises rapidly, exceeding the melting points of all known materials. Any attempt to send a lander would be met with a swift and destructive end, first battered by the winds, then fried by the heat, and finally crushed by the immense pressure. Radiation presents another formidable obstacle. Jupiter is surrounded by powerful belts of radiation, generated by its strong magnetic field. These belts are far more intense than the Van Allen belts that encircle Earth. Probes like Juno, which currently orbits Jupiter, must be heavily shielded and follow carefully planned paths to avoid damage. For human explorers, the radiation levels would be fatal in a matter of hours without unprecedented protection. Even if technology advanced to allow a probe to descend deep into Jupiter's atmosphere, the journey would become increasingly perilous. As the probe sinks, the hydrogen gas is compressed to the point where it turns into a strange, metallic liquid, conducting electricity and creating a bizarre alien environment. Eventually, the probe would be destroyed. If not by temperature and pressure, then by the sheer weight of Jupiter's vast atmosphere. Some might wonder if there is a solid core deep within Jupiter, a place where, in theory, one could land. While scientists believe that Jupiter may have a core of rock and metal, it is buried beneath tens of thousands of miles of crushing gas and liquid. No probe could survive the journey, and even if it could, the core itself would be an unimaginably hostile, high-pressure environment, utterly inhospitable to humans or machines. Jupiter's immense gravity also poses a challenge. With a gravitational pull over 2.5 times stronger than Earth's, escaping the planet would require an enormous amount of energy, far more than any rocket we have ever built. So, while we may send orbiters and atmospheric probes to study Jupiter from a respectful distance, the dream of landing on the gas giant remains firmly in the realm of science fiction. Jupiter will continue to captivate our curiosity, reminding us that some worlds, no matter how alluring, are simply beyond our reach. In exploring its mysteries from afar, we gain not only knowledge, but a humbling respect for the formidable forces that shape our universe.